everyone, this is Benedek here, very welcome to my channel. Now in today's episode we will be discussing about merge sort algorithm. I will try to explain what it is, why it is useful, and I will try to show you how to implement it in C#. Alright, so first let's talk about what it is actually. Well, merge sort algorithm is a sorting algorithm which is actually based on the divide and conquer paradigm, and in this algorithm the idea is that the array or list or the input collection is first initially divided into two equal parts, like a left and the right sub sequence basically. And they are combined in a sorted manner afterwards. So think of it as it's kind of a recursive algorithm which continuously splits the array halves or the list halves until it cannot be divided into basically further parts. So this means that the array or list becomes empty or has only one element left, and those elements are compared to each other and then merged back again, sorted. Okay, just one note that I don't know if big O means something to you or not, but I thought to mention that its efficiency is big O of n log n, and we have to say that, for example, insertion sort is better than this one. Alright, let's start. Let's check it in code, and probably I will show you some diagrams to better, familiarize with the concept of this algorithm. Okay, let's get into it. Okay, here I have created a little example of this merge sort algorithm, but before I go into too much detail, I first have to say that I've already mentioned that insertion sort is a little bit efficient, more efficient than this algorithm, but if we compare this merge sort to, let's say, bubble sort, then merge sort is better or a little bit more efficient than bubble sort. Alright. So as you can see here, it is an example of merge sort. Obviously, let's think about these boxes and these numbers as a kind of input array or like an input list, which is unsorted or unordered. So these numbers are obviously not in an increasing or decreasing or let's say ascending or descending order. They are just placed in randomly, and the thing is that what merge sort does, it is splitting them up into arrays of one element, and then it compares which one of them is the, let's say, the smaller, and it merges them back again ordered or sorted in a sorted manner, and it goes with those numbers as well, and in this way they are getting merged back again, sorted, and as you can see, it is a sorted collection after all. Alright, so this was a little bit of an overview, and let's see it in code. Alright, I have created a simple little empty Visual Studio Code project, Visual Studio project for this demonstration. So let's check how to implement merge sort in C#. Alright, so first we need to have an unsorted list as a collection. So let's say unsorted list, and we will obviously sort those numbers which go inside here. So let's just randomly put in some numbers like 800, minus 900, 5, 43, let's say 1200, 888, 48, 10, 23, let's say that's enough. All right. So we would like to have this list sorted. Okay. First, we will create a method for this, for the merge sort. Let it be public static, and it will return the new list, which would be the sorted list. Because of this, we will have to have this to be a return type of an integer list. So it will return an int list, and it will be called merge sort. Alright, and it will take in a list of type integers as an unsorted input list. Alright. Okay, first things first, we need to check the size of this array, because let's imagine someone creates an array as an input or a list, sorry, as an input list, and the list can only so the list can contain even just one item. So we have to, you know, be prepared for that as well. So let's say we will check for the count. So the number, the count means the number of the elements in the list. So if it is below 2, we will just simply return the unsorted input list as is, and return also hands back the collection and stops this function. But if it is over 2, or it is 2, then it you know, this program continues here. So what to do next? We, as I have mentioned in the example and in the intro, we need to, you know, split this collection, this list into 2 parts. To do that, first I need to know the middle point of this. So I need the middle index. It will be an integer, and I will, you know, give it descriptive name of middle index, and the unsorted input lists count, so the number of elements divided by 2. And by the way, note that it won't be a floating point number, as I didn't use float for it. So if I would put in float, for example, then obviously it would be a floating point number if 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's put in another element. So it has 9 elements. So if it would be a floating point, you know, value, it could have the value of 4.5, but it will be an integer, so that will be rounded, of course. All right. But it was just for demonstration, so we can, you know, erase that one. Okay. Right, so let's create that 2 lists, the left and the right side, and it will be initialized as an empty list. And let's create the right side as well. Okay, and how to fill them up? Well, first to the left side, obviously, those values would come that are the you know, from 0th element of this list to the middle point. So I will iterate from the 0 to the unsorted lists count, meaning that or sorry, no, to the middle index, because we will only, you know, place the half of it to the left of BST. So we will, you know, give the values of the input list into the left side till the half of the collection. Then obviously we will do the same for the rest of it, but here we are not going from the beginning but from the middle point, and we are going to the end of the collection, so that would be that would mean the right side of the collection. and obviously here we are not filling the left hand side, because if I would leave it as is, then all of the elements would just go to the right side, but sorry, to the left side, but here I need to put in the right side. Okay. As I have done that, then I would like to further divide these subarrays or sub-collections, sorry. So I need to do the same thing actually for the left list and the right list. To do this, I can simply call the merge sort, which I have just implemented, or I am just implementing right now, with this collection actually. So I can use recursion for this one, like that. And here I can reassign those with the returned value, which would be the merge sorted int, int list. Yeah. And of course, one very important step is that we need to merge those lists back again, and we need to return it. So I will have a merge method, which I have currently not implemented yet, but I will just within a sec or within a minute, let's say. And this method, this merge, will take the two parts and create a unified and sorted array list here, and give it back. Okay, so create that method. It will be a public static, and it will return an integer list, and it will be called merge, and it will have two integer lists as an input parameter, obviously, here as you can see. Let it be left side, and let it be right side. All right. And here we need to create a new list, which will be the result list, or let's say the merged list, and it will be a new list of type integers. And here we need to do the check to see which one is bigger, so basically here we need to do the hardest part of the logic, I would say, or not hardest, but yeah. So we are iterating through these collections while they are having elements, meaning that if the size of the left side list is bigger than 0, and if the size of the right side list, the right side list is bigger than 0, so sorry, not and but or. So basically we are going through those lists until they are both emptied, or yeah. So basically that's it. All right, let's check if both of them has values, or sorry, if any of them, yeah. So here we are checking if any of them has values, and here we are checking if both of them still has value. Right, okay. Go further. Here we need to check the first element of the left side. So get the first element of that collection, and we need to check it against the right side's first element. Right, like that, and it should be lower smaller or equal to that one, meaning that it will be the smaller, and if so, then we will add this value, the smaller value, to the merged list, because we are going to make it sorted ascending, in an ascending way. So we are adding it. But if I would leave it, it will be an infinite loop, so it would never end and probably fill up the RAM of my computer, which is not a very good thing. So to break out of this, we need to obviously delete the element of the left side after we added it to the merged list. So we need to call the remove function, and we need to remove the thing we have already added to the merged collection, like this. And after it, we need to also check the else case. So if this is bigger, basically, in that case, obviously, if this is smaller, in that case, obviously, we will add the right side's first value to the merged list and remove from the right side the first element. Okay, but what if, let's say, we would have a collection with an uneven or with an odd value of numbers, so the count is not even, let's say. So let it be 3 and let it be 4, meaning that it will be reduced probably first, and it would have values later. To tackle this, we need to check these separately as well, I would say. And here, if the left side is not emptied yet, then obviously anything from the left side we would like to put to the merge list and just remove it. And in case only the right side has values left, then obviously we would need to check that, and if that's the case, then we need to remove the first element of the right side, add it to the merge list and then remove it from the collection, right, like this. I hope it makes sense. All right. And one important thing is that after this while loop, we need to obviously return something, as it says that we are not returning anything. We would like to return the merged list, obviously, like this. Okay, let's check it. All right, so this is the unsorted list, and I want to have it sorted with the merge sort algorithm. So I want to say merge sorted list. Okay, or no. I will call the merge sort method in on this input result or input set, and this will be the result, and we will iterate through it. Or maybe it's nicer to iterate with a for each, because we don't need the index. And let's check what will be the outcome. Okay, and I have to put in a console read key so that I can, I would be able to see the result. So if I hit F5, as you can see, they are sorted. So these were this list was the input, and these are sorted in an ascending way. All right, so it is working. Okay, but how to sort? How to use merge sort in a descending way? It is very, very simple. You have to, as I have mentioned, in the merge method, we are deciding on the way of sorting here, actually, when we are checking the elements and putting first the one which is smaller. But of course, we can, start with the bigger one as well, and try it. And as you can see, now it is in a descending order, so that's simple it is. All right, I hope you liked it, and if so, please give me a thumbs up and consider subscribing if you haven't did that already. And have an absolutely wonderful day wherever you are. Be safe out there. Bye.